So let's say that we have f of x equals x squared plus 5x minus 2. And we're allowed to use Desmos to get a visual. And that visual would look like this here. Something like that. And let's suppose that we have a point, let's say like right there. And all we know about that point, all we're given is that the x coordinate is -4. Now you need a goal, and the goal would be as follows. The goal is going to be this: for us to draw, or for us to write the equation of the yellow line. That is the goal, right? So goal, equation of tangent line. That is the goal. This line is in yellow. It is a line, and the equation of a line is going to be the good old y equals mx plus b. Now, in order to do this, you need two things. One, you need a point, and two, you need a slope. That is what you need. 1 point and 1 slope. Let's take care of the point first. We are in luck. We know that a point has coordinates, and they have given us the x coordinate, -4. Now, to find the y coordinate, what you have to do is take -4 and plug it into your original equation, right? You go to the original equation up here, you go to the original up there, and you plug in the x coordinate into all the x's. And that'll tell you the corresponding y coordinate. Let's do the work down here. So f of -4 would equal, in parentheses, and this is like 16 minus 20 minus 2, which I believe is -6. I want to say that it's -6 for the y coordinate. I would go back in there. The y coordinate is -6. So let me erase this to get some space. So we have the point. Now, all you now need is the slope, and then we can build our answer. So it is a fact that I want to jot down. The derivative of a function reveals the slopes of tangents. And I want to emphasize this with a lot of exclamation points, because this is a fact that I sort of rehearsed to myself over and over and over. The derivative of a function can tell you the slope of any tangent at any point that is on your shape. So let's find the derivative. We have to find the derivative right now. And here is the definition of a derivative. Let's grab a marker. So your derivative is this definition here. So derivative. So we have f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. We spent a month doing limits to prepare us for this section. And we actually did this box here like in the first week of school. We just didn't know what we were doing until this chapter. So recall that to do this stuff in the box, h is just h. F of x is the original equation up here. What you have to find is this puzzle piece here. Let's find f of x plus h first before anything else. Let me erase some of this here. So let's find f of x plus h. So f of x plus h would equal x plus h squared plus 5 times x plus h minus 2. And this would equal x squared plus 2xh plus h squared plus 5x plus 5h minus 2. And all this here, we will copy and paste that into our derivative definition. So we would have f prime of x equals the limit as h approaches 0. So in the top left, we have all of those pieces that we just wrote down. And then we go minus, and then in parentheses, you copy the original function. And all of this is above h. Now, if you made observations from the limit chapter, you'll maybe hopefully have noticed that whenever you do this difference quotient idea, a lot of times this happens. You see this x squared, it's going to be negative x squared, and it's going to cancel with this one. So look, this piece wipes out with this piece, gone. Also, you see that 5x, that's going to be negative 5x, and it'll knock out this one. Gone, gone. You see that negative 2? That negative makes it positive. And then when that positive 2 happens, it knocks out this negative 2. So this is gone with this. And all the pieces in the back, they're gone. So you could actually ignore this as well. This is all gone. And all the pieces that have survived here in pink, this one, and this one, what do all of them have in common? They all have an h. They all have an h in common. So this would equal the limit as h approaches 0. And why don't we actually factor out an h from all the pieces that are left in the top? Take out an h from all of the pieces that are still left in the top. Because what happens with these h's, you see this h in the outside and this h in the bottom? They reduce away. They knock each other out. And then when that happens, when the h in the bottom disappears, that is your cue to plug 0 into h, because h is supposed to get close to 0. So I plug 0 in for h into all the remaining h's, which is only this one. So if this goes to 0, it disappears. And the only thing that you're left with, the pieces that you're left with, constitute your derivative. So here in blue, f prime of x would equal 2x plus 5. Write that down somewhere. Hopefully you're following along here with this little video. Our derivative is 2x plus 5. Pause the video if you want, because I'm about to delete almost everything. We found the derivative, 2x plus 5. Let's get rid of some of this stuff here. So we know that our derivative is 2x plus 5. Let's see, f prime of x equals 2x plus 5. So let's come back home. What were we trying to do? We're trying to write the equation of the yellow line. And to write the equation of a line, you need a point and you need a slope. The point we found 10 minutes ago by plugging the given x coordinate into the original to get the y coordinate. All we need now is the slope. And the slope is represented by the letter m from like freshman math. Remember, y equals mx plus b, m is the slope. So how do I find the slope? You go to the derivative and you tell the derivative your x coordinate, boom, this guy. You take your x coordinate and you plug it into your derivative. And let's see what happens. So f prime of negative 4 equals 2 times negative 4 plus 5. So negative 8 plus 5 is negative 3. And that, my friends, is the derivative. But what it does here, what it plays the role of, is it plays the role of the slope of your yellow line. And that's so appropriate because look at the yellow line. It has a negative slope. So we have a point and we have a slope. Let's finish this problem and this video. So we know that our slope, m, equals negative 3. And that goes in for m. So we have y equals m x plus b. So now to find b, you take the point and you plug it in for x and y. That's the whole point of using the point, to plug it in for x and y at this point to discover your b. So negative 6 equals 12 plus b. Subtract it. b equals negative 18, which goes back in there for a final answer of negative 3x minus 18. And this is the equation of your yellow dotted tangent line. So in summary, when you're given a function, you can plug in the x coordinate into the original to get the y coordinate. You plug the same x coordinate into the derivative, which I erased, but you plug the x coordinate into the derivative to get your slope. Once you have your point and your slope, you go y equals mx plus b, and you get your a plus.